Here I have a problem from the AMC 12 math competition in the year 2011, and we have a bit of a geometry problem today. But first, before we get into it, I just want to say thank you for continuing to watch my videos, even though I haven't been posting in the last couple months. I've been really busy, but your guys' continued support is the reason I'm going to be consistent in uploading on the channel once again. So I just wanted to say a quick thank you for that. Now let's jump into this problem. So first, we're given this rectangle ABCD, where side length AB, and obviously because it's a rectangle CD as well, is a length of 6, and the shorter side BC and AD are both of length 3. And then we're told to fashion this point M along this line segment AB such that angle AMD is equal to angle CMD, and then we're told to find the measure of angle AMD. So the first what I want to do is kind of complete this triangle really quickly. So let's complete this AMD triangle with a dotted line. Good, so now we have our little triangle AMD, and we also have our angle AMD that'll be here. And then with this red color, I'm going to go ahead and complete the triangle MBC as well, because that's going to be a little bit important to our problem. But now I want to point out that line segment AB is perpendicular to line segment CD. Now this is important because the line segment MD intersects both lines. Now this is important because our line segment MD intersects both AB and CD. And because MD is a line segment, it's not curved, that means that our angle AMD is congruent or equal to our angle MDC or CDM. So let's go ahead and put that down. Our angle AMD, which is our target angle, is equal to or congruent to our angle CDM. Now, one more thing to note is that we are given that angle AMD is congruent or equal to angle CMD, so this angle here, by construction. So that means that this triangle here is isosceles because these two orange angles equal each other, which means that their sides are also of equal length. And because this bottom side, CD, is length 6, that means MC is also of length 6 because it's opposite this angle CDM that we marked up here. So using our given statement, which is that angle AMD is equal to angle CMD, we know that triangle CMD is isosceles. So now we're ready to solve for this angle AMD. What we want to do, because we know that these two angles are equal, we can write 2 angle AMD plus angle BMC is equal to 180 degrees, or pi radians, because we know that this line segment AB is straight and thus adds up to 180 degrees. And like I said, because AMD, the angle AMD is equal to the angle CMD, we can just combine those into 2AMD. But now all that's left to do is solve for BMC, and then we can solve for AMD. But how do we solve for angle BMC? Well, what we need to do is realize that this line segment here, BC, is equal to 3, and that this line segment CM is 6, but that's actually a hypotenuse of a right triangle with right angle here at MBC. So the sine of angle BMC is equal to the opposite, I'll go ahead and write this in blue, the opposite, which is 3, over the hypotenuse, which is 6, but that simplifies down to 1/2. But that means that angle BMC is pretty obviously equal to 30 degrees. But now with that information, we can bring this up into this equation up here and then solve for AMD. So let's go ahead and do that in the top right here. So we have 2 angle AMD plus 30 degrees is equal to 180. But then we want to subtract 30 degrees from both sides, and we get 2 angle AMD is equal to 150 degrees, which means that angle AMD is equal to 75 degrees. And that's our final answer, and I think that's enough for now.